Hello students, now let's learn how to formulate polynomials from roots. Suppose I have an example here. I'm just following the same examples as in the foldable, so it will be easy for you. So have a root at -4, 2 and 3 according to the description. I'm just trying to draw a graph based on that. So, um, so our title is Formulating Polynomial Functions, okay? Polynomials from roots. So in this case, you'll have three values for x. X is at -4, x is at 2, and x is at 3. So this is the first step, make them uh, equal to x, and because sometimes they'll be listed. So the next step is to make zeros out of each root. So it's x plus 4 is 0, x minus 2 is 0, and the third would be x minus 3 is 0. So all you have to do is multiply them through. So you just multiply the linear factors. So you literally multiply them. So we can start with any group. I chose these two. So you can even choose the first two or the first and third because of the associative property of multiplication. So anyway, so this is x squared minus 5x plus 6. Now we have to actually multiply by the Marx method or the lattice multiplication as they call it, right? And this is x plus 4 and multiply it through. Okay, so now f of x, always write your answer with the function f of x or g of x or whatever is. So you have to first write this function's name for sure. Now add up all of these terms, x cubed, so minus x squared minus 14x plus 24. That's the answer. Okay. Now we'll actually do the second example. Before that, we have to talk about multiplicity. Multiplicity. Multiplicity, as the word is suggesting, it is giving you some kind of multiple roots for the same value. So in the graph that is provided, you see that the graph is bouncing off here and bouncing off again at 0. Oh, so actually it is crossing the x-axis. Let me draw this clear. I'll take my own example. So suppose the graph is bouncing off, going up, and it's kind of wiggling at the x-axis and crossing it. So whenever it bounces off the x-axis, right, it is supposed to be an even powered root. So which means that, as you can recall, if just this part would be a quadratic, isn't it? Just this part. So whenever it bounces off, it becomes an even power. So this becomes, so let's say this is at -2 and this is at +3. So at x equal to -2, at x equal to -2, it's bouncing off. And let's say it is a double root. So multiplicity is 4. So this, when you write as a linear factor, you would say it is squared, right? And when it wiggles off at the x-axis and crosses it, this becomes an odd power root. So here, so it graph bends or wiggles, so the root has multiplicity 3, meaning it is x minus 3 cubed. That's what it means, and which is f of x. So you can multiply it through and write the answer. So I'm just giving you an example. The foldables example is also fine. Okay, so that's what it means by multiplicity. Multiplicity is giving like the number that of times that or I should say the exponent, right? It's the number of times it is multiplying itself when you write it algebraically. Okay, so now let's to look at the right side of the foldable where you actually have to um, practice this skill. So we'll start with the first example. I'm not going to do everything, but I'm just giving you a hint. So here first make it equal to x, -1, x is -1, x is 2/3, and x is 4. So from the first one, it's x plus 1 is 0. From the third one, it is x minus 4 is 0. But when it's a fraction, recall we did this in the last unit. We want to get rid of the fractions. I don't want fractions in the actual polynomial. It becomes really hard to multiply and write it as a standard form. So it's always better to multiply the denominator on both sides. So this becomes 3x minus 2 equal to 0. And now you would multiply. F of x is x plus 1 times 3x minus 2 times x minus 4. And you do the multiplication, okay? I'm not going to do it. I'll stop it here. I'm just giving you hints on how to do this. The second one is pretty straightforward. It's just like our example given in the teacher notes. So the third one, he says 2 is a double root, meaning it is multiplying itself 2 times and there is a -3. So whenever you see a double root, it means that this, right, this root x minus 2 is going to square, and there is nothing happening here, so it remains x plus 3. So f of x is actually x minus 2 squared times x plus 3. And you multiply it through, please, and write your answer. Next, we'll go to a different example. Trying to scroll this up. Okay. So, oops, hold on. Where is my thing? Here. Oh. Now the next question I want to do is the fourth one. The sixth one, it says multiplicity. So let's just finish the sixth one also. It's similar. So he says multiplicity is 3. Multiplicity is 3. And there is another root with 0. So this becomes x plus 4 cubed times x. Okay. And multiply and write it in standard form. Okay, all these terms must be written in standard form. All right, so that's the sixth one. And fourth and fifth are similar in the sense if they are radicals or imaginary numbers, they come in pairs. So you'll have 2 plus or minus. So the fourth question is 2 plus or minus I and 1. And the fifth question is 6 plus or minus square root of 3 and 3. Both both working process is just the same. So let's see how that goes. Okay. So recall from our previous unit that when you have imaginary numbers, when you go backwards of the completing the square method, it's always easier to subtract the 2 and bring it to the left side. This is x minus 2 is plus or minus I. So then you would just square on both sides, right? You would square on both sides. And so when you multiply this, x minus 2 times x minus 2 becomes x squared minus 4x plus 4. And on the right, you'll have a -1 because I squared is -1. Plus or minus, it becomes positive when you square it. All you have to do is add 1 on both sides. You'll get x squared minus 4x plus 5 equal to 0. Okay, and the other root now is simple. It became x minus 1 is 0. So now the f of x would be a product of x squared minus 4x plus 5 times x minus 1. Okay, and do the box multiplication and all that and write it in standard form. I'll leave that part to you. So the same working process is for this. Equate this to x equals 6 plus or minus root 3. Subtract the 6, square on both sides, and you can easily do it. Okay, I'll leave you here. You're supposed to do the backside of the day one handout that was taken last week. So this foldable and that, and glue this foldable onto your notebook. I'll check your work next class. Okay, thank you for watching. Have a great one.